So this video is going to talk a bit about dissolved oxygen and why we should care about that. So dissolved oxygen is we're talking about oxygen in water. It is O2, not the O in H2O. So I even have here the molecule, the O2. It's an O bonded to an O. It's a double bond. And that is what the oxygen in the air we breathe is the same oxygen that fish will breathe. It just dissolves in water. And when I say a gas dissolves in water, think about a carbonated beverage. There's different gases like carbon dioxide that dissolve in that beverage, and that fizz is those gases being released in there. So there are gases dissolved in water, and one of those gases is going to be oxygen gas, and that is what organisms will need. And why do they need it? They need it to do aerobic respiration, just like as humans or mammals that breathe air need O2 from the air to do aerobic respiration. So big idea, it's the O2 from the air and then it dissolves in the water, not this O, not this oxygen in H2O. So next slide is just going to take us through, again, O2 is the O2, the gas in between it's O2 gas, and it dissolves or kind of hides between the water molecules. Typical survival levels for fish are 5 to 8 parts per million. And so what I want to do here is just show you, it's good review of like percent stuff, but here, part per million means 8 out of a million. Percent means out of 100. So I took 8 out of a million is what percent out of 100. I cross multiply and I get 800 equals a million times my X or times my percent. And so I then divide both sides here by a million to solve for X, and I get 0.0008%. The air, as you'll recall, is about 21% oxygen. So why that's significant is what we're going to talk about with some things like with nitrate and phosphate in BOD or dissolved organics, is that the oxygen level, the dissolved oxygen level in waterway can go low and it can cause fish to die. Why is it then that if there's fertilizers on the ground, it doesn't impact us as humans? Or why if there is like organic food or organics or, food sitting around, we don't run out of oxygen? And the reason is because of the difference in the oxygen levels. The air is 21% oxygen, and water, a good amount of dissolved oxygen is 0.0008%. So it's crazy the difference in those amounts. So what can be done to increase the dissolved oxygen levels is, here, let me go to, is you can have aeration. So aeration is adding air. So mixing the air, since it's 21%, and again, such a much lower percent in water. Fountains could be an artificial way. Natural things like rapids and rocks and churning water or waterfalls will aerate the water. Photosynthesis, remember, photosynthesis during the day is going to release oxygen. So if you have plants or algae in your water, that's going to increase your dissolved oxygen during the day. Remember, at night and all the time, plants are doing respiration. So if there's no sun, there's no photosynthesis, and then you can actually reduce your oxygen levels at night, and we'll see that in a second. And colder waters hold more oxygen too. If you're into fishing, often they'll talk about cold water fishing. Again, there tends to be higher levels of dissolved oxygen in colder waters. So these are ways you can increase dissolved oxygen. Decreasing it, stagnant water. Stagnant, that word means still. So water that just sits there. So if you've seen a lake and the water's just sitting there and there's no air, there's no wind and there's no waves, again, the dissolved oxygen levels are going to get lower or just kind of stay there. They're not going to be mixing with the air to get oxygen in there. Aerobic respiration, opposite of photosynthesis, it's going to take in oxygen. So aerobic bacteria in the water will use up dissolved oxygen. We will see that later. Or again, plants, algae, do photosynthesis and respiration during the day, but when there's no sunlight, no photosynthesis, so just respiration, and they could cause dissolved oxygen to go down. And warmer water tends to hold less dissolved oxygen too. And we'll see that's significant when we talk about global climate change, warming of the oceans. They're going to hold not just less oxygen, but less CO2 and issues with that. So again, this gas solubility issue with that. So lastly, again, so much less oxygen in there. So how in the world do fish survive? And fish have these things called gills. So I'll go to the next slide here. And that's a close-up picture. It looks very bloody. And basically, there's a very thin membrane, and that is like their blood. And if you've gone fishing or you've seen people grab fish sometimes like in their mouth by their gill and there's blood, it's because that's a very thin membrane. And basically when they swim, the water crosses over their gills. And as it crosses over the gills, the oxygen, the dissolved oxygen can cross over that membrane. And then that dissolves into their bloodstream. Fish don't have lungs. So the way we as humans operate is we have lungs. We do not have gills. So that's why we can't breathe underwater. But fish use their gills. They get basically the oxygen crosses over that that membrane into their blood and then circulates around, and they're able to survive, assuming that there is enough dissolved oxygen. Environmentally, what can happen? Environmentally, if the dissolved oxygen gets too low, the fish will suffocate. Just like as humans, if our oxygen levels get too low, we would suffocate and die. Same thing happens with fish. Too high is very, very rare. It's actually called like a gas bubble disease. Basically, it doesn't happen, or don't worry about it. But it would be like, and that's what this image is showing, bubbling out in like the gills, and then the fish basically can't get the oxygen because they're not getting that transfer of oxygen. But don't even worry about that. The concern is really if dissolved oxygen gets too low, it can kill fish. So that is dissolved oxygen. It's a really, really, really important parameter. It is going to factor into BOD and nitrate and phosphate and so many other factors that we'll be looking at. So that's why you got to understand DO so that you can then understand those. I hope this video was helpful.